Hi everyone, welcome to my YouTube channel Gyan Guru by Gaurav Gupta once again. Now friends, as you all know that in these videos we are discussing the NCERT exemplar booklet and all the questions which are given in that booklet in the practice exercise we are discussing. We are taking all these questions one by one in these videos. So today we are going to discuss trigonometry, that is chapter number 3. Now I will divide the entire exercise in different parts because there are so many questions. So I don't want to make a very long video. So I will divide these questions in the exercise in 3 or 4 different parts. And today we are going to discuss the first few questions which are of short answer type. Now, though it says they are of short answer type, but actually they are not. The questions, some of them are pretty lengthy to prove. So let's quickly start without wasting any time with the first question where we have to prove that tan A plus secant A minus 1 upon tan A minus secant A plus 1 is equal to 1 plus sine A upon cos A. Okay. I shall start with the left hand side where you are given tan and secant and will convert them in terms of sine and cos. So LHS to start with. So tan A, I can write it as a sine A upon cos A plus 1 upon cos A minus 1 whole divided by sine A upon cos A minus 1 upon cos A plus 1. Now take LCM separately in numerator and denominator and you will observe that cos A will get cancelled from the denominators of both numerator and denominator. Okay, so the simplified expression for the LHS will be sine A plus 1 minus cos A whole divided by sine A minus 1 sine A minus 1 plus cos A. Okay. Now what you can do is you can multiply and divide this expression with the sine A plus cos A plus 1. Okay, so sine A plus cos A plus 1 से multiply and divide कर लो. So plus cos A plus 1. All right. Now in the numerator, we will multiply these terms in a normal manner. Okay, and we will obtain 9 different terms in the numerator. So let's do that. Sine A multiply sine A, then sine A multiply cos A, then sine A multiply by 1, and so on. You can just open the brackets in a normal manner. Okay, so numerator will become sine square A plus sine A cos A plus sine A. Be very careful while you are writing this expression. Plus sine A plus cos A plus 1 minus cos A sine A minus cos square A minus cos A. All right. Now in the denominator, what you can do is you have sine A plus cos A minus 1 sine A plus cos A plus 1. So you can make the formula of A plus B into A minus B, which is A square minus B square. So it can be written as sine A plus cos A whole square minus 1. All right. Now let's simplify the numerator. So let's see what all things can be cancelled. So sine A cos A is the first thing that I can see which will get cancelled. Okay, then cos A will also get cancelled, cos A minus cos A. All right, now I have sine square A. Okay, and you can combine these two, 1 minus cos square A. 1 minus cos square A will become sine square A. So I will have 2 sine square A in the numerator, and then sine A plus sine A will be 2 sine A. All right, so the numerator is simplified. Now look at the denominator, sine A plus cos A whole square. So it can be written as sine square A plus cos square A plus 2 sine A cos A, and then minus 1 as it is. Now look at the denominator. Denominator में sin square a plus cos square a will become 1. 1 minus 1 will be nothing, will be 0. So in the denominator, you will be left with only one term, which is 2 sin a cos a. Okay. Now look at the numerator. Numerator में से 2 sin a common ले सकते हैं हम. So if I take 2 sin a common, you will be left with sin a plus 1. And in the denominator, I have 2 sin a cos a. 2 sin a will cancel from numerator and denominator. So in the numerator, I will have 1 plus sin a. In the denominator, we have cos a. And that is what we have to prove. So that was question number 1. Okay. Now, quickly moving on to our next question, question number 2. Now, question number 2, the hint is already given, so you can use this hint. And basically, this is nothing but whatever we have done in the first question, they have done the same thing. Okay. So we are starting from here. Okay. And we'll have to prove that this is equal to this. Okay. Right. So they have already given a hint. We will continue from there. So 1 minus cos alpha plus sin alpha divided by 1 plus sin alpha. What they have done is they have multiplied and divided it by 1 plus cos alpha sin alpha, 1 plus cos alpha sin alpha, both in numerator and denominator. So now we'll do the simplification the way we have done in the first question. Okay, जैसा first question में simplification किया था, exactly in the similar manner I will multiply these two terms in the numerator. So numerator की terms को multiply करते हैं, so it will be 1 plus cos alpha plus sin alpha minus cos alpha minus cos square alpha minus cos alpha sin alpha, then plus sin alpha plus sin alpha cos alpha plus sin square alpha. In the denominator, I will not multiply because we have this term which we require on the other side. Okay, so ये वाली term तो चाहिए, so इसको dilute नहीं करेंगे, and I will keep the denominator as the product of 1 plus sin alpha and 1 plus cos alpha plus sin alpha. All right. Now simplifying whatever is there in the numerator. So let's cancel out some terms. So cos alpha sin alpha will get cancelled. Okay. Then cos alpha will also get cancelled. I have 1 minus cos square alpha, which will become sin square alpha. And I also have plus sin square alpha. So I will have 2 sin square alpha. All right. Then we have sin alpha plus sin alpha. That will become 2 sin alpha. Okay. In the denominator, as it is, 1 plus sin alpha, 1 plus cos alpha plus sin alpha. Now from the numerator, you can take 2 sin alpha common and you'll be left with the sin alpha plus 1, which will get cancelled in the denominator. Okay, denominator maybe we have 1 plus sin alpha, so these two will get cancelled, and 1 plus cos alpha plus sin alpha will be the only thing that will be left in the denominator. Okay, so after cancellation, I will have 2 sin alpha whole divided by 1 plus cos alpha plus sin alpha, which we require on the other side. Okay, so this is equal to y, and we have proved whatever was required. Okay, so that was question number 2. Let's look at question number 3. Now, question number 3 is pretty easy. Again, they have given a hint, but without a hint, how should we look at, how should we go in that direction? Now, let's look at this part. Here we have m plus n divided by m minus n. Okay, now once we have m upon n, then how do we obtain m plus n upon m minus n? By applying componendo and dividendo. We know this is a very basic thing, elementary thing that you have learned in previous classes. Okay, so this is how you think in the direction of the question. Okay, now from the given part, which is m sine theta is equal to n sine theta plus 2 alpha, I can obtain m upon n. Okay, so m upon n after cross multiplication will look like Sine theta plus 2 alpha whole divided by sine theta. Okay. Now you can apply componendo and dividendo. So it will become m plus n divided by m minus n, and that is equal to sine theta plus 2 alpha plus sine theta, and denominator sine theta plus 2 alpha minus sine theta. Okay. I'll leave left hand side as it is, which is m plus n upon m minus n, and will operate on the right hand side. So right hand side में sin a plus b का formula apply कर देते हैं, which is sin a cos b plus cos a sin b. So it looks like sin theta cos 2 alpha plus cos theta sin 2 alpha, and then plus sin theta as it is in the numerator, whole divided by again the same formula sin theta cos 2 alpha plus cos theta sin 2 alpha minus sin theta. Okay. Now what you can do is in the numerator, from the first and the third term you can take sin theta common, and so does in the denominator. Okay. So taking sin theta common, you will be left with cos 2 alpha plus 1, and then cos theta sine 2 alpha as it is. In the denominator, do the same thing, take sine theta common, and here you will be left with cos 2 alpha minus 1 plus cos theta sine 2 alpha. Okay. Now in the numerators and the numerator and the denominator, look at the terms inside the bracket, both of them. So first of all, in the numerator you have cos 2 alpha plus 1. Now remember the formula of cos 2 alpha. So first of all, cos 2 alpha is 2 cos square alpha minus 1. Minus 1 will go on the other side. So you can say that cos 2 alpha plus 1 can be written as 2 cos square alpha. Alright. And completing the numerator, cos theta as it is. Now after cos theta I have sine 2 alpha, which can be written as 2 sine alpha cos alpha. Now do the similar thing in the denominator. Now here after sine theta in the denominator we have cos 2 alpha minus 1. Okay. Now I'll write it separately with a red pen. Now cos 2 alpha is equal to 1 minus 2 sine square alpha. Okay, so cos 2 alpha minus 1 will be minus 2 sine square alpha. So minus 2 sine square alpha. This term is very important. That is why I've written it with a different color. And then the remaining part, cos theta, and then 2 sine alpha cos alpha. Right? Okay. Now let's rearrange the denominator and numerator and simplify. So from the numerator I can take 2 cos alpha common. So 2 cos alpha common लिया. So अंदर क्या बचेगा? I will have sin theta cos alpha plus cos theta sin alpha. From the denominator you can take 2 sine alpha common, and after taking this common I will have minus sine theta sine alpha plus cos theta cos alpha. Okay. Now 2 will get cancelled, numerator and denominator. Cos alpha upon sine alpha will be cot alpha. Okay. Now in the numerator inside the bracket, sine theta cos alpha cos theta sine alpha. This will be the formula of sine theta plus alpha. In the denominator, cos theta cos alpha minus sine theta sine alpha will be the formula of cos theta plus alpha. Now you can write the simplified form. So cot alpha as it is. Sine upon cos is tan, so this will become tan theta plus alpha. okay, which is what I have to prove on the other side, and hence the question 3 is also done. Okay, so this one was not at all difficult, but I can say that a lot of steps had to be written. Okay, now moving on, next question, question number 4. Now, I don't know any of you has observed this thing or not. There are some errors which are there in the exemplar booklet, errors in the practice exercise, errors in the answer keys. Okay, so I will be pointing out those errors and will be rectifying. Okay, so I'll not be continuing with those errors. I'll not be neglecting those errors. Fine. Now, cos alpha plus beta is given as 4 by 5. So, let's say I'll make a triangle whose angle is alpha plus beta. Okay, so cos alpha plus beta is 4 upon 5, that is base upon hypotenuse. So, if base is 4, hypotenuse is 5, then I can say that the perpendicular or the height will be equal to 3 using Pythagoras theorem. Now, similarly, do it with alpha minus beta. Okay, so let's say this angle is alpha minus beta. So sine of alpha minus beta is given as 5 by 13. So height will be 5 and hypotenuse will be 13. And applying Pythagoras theorem, 13 square minus 5 square is 169 minus 25, that is 144. Under root of 144 is 12. Okay, so the base will be 12. Also, you can find out all these things by remembering some basic Pythagorean triplets, right? So now I have this triangle. I have to find out the value of tan 2 alpha. Now you can pick it from the hint. Also, common sense, all the values are given in the form of alpha plus beta or alpha minus beta. So we'll have to introduce beta in some manner. So I'll write 2 alpha as alpha plus beta plus alpha minus beta. So basically what I have done is I have added beta and subtracted beta in 2 alpha. Okay, so plus minus beta kar diya maine. Now apply the formula of tan A plus B. Tan A plus B. That will be tan A plus tan B upon 1 minus tan A tan B. So let's apply that formula, tan alpha plus beta plus tan alpha minus beta whole divided by 1 minus tan alpha plus beta into tan alpha minus beta. Okay, now you can refer those triangles to find out the values of tan alpha plus beta as well as tan alpha minus beta. Okay, so first of all, the value of tan alpha plus beta. Look at the first triangle. What will be tan of this angle? It will be perpendicular upon base, that is 3 upon 4. So 3 upon 4 plus tan alpha minus beta in the similar manner will be 5 upon 12. Continue, put these values 1 minus 3 by 4 multiplied by 5 by 12. Now simplify this expression and get your answer. Okay, so the numerator will become 12 plus 5, 9 plus 5, 14 upon 12, and the denominator 48 minus 15, that is 33 upon 48. Okay, 12 and 48 will get cancelled. Now 14 multiplied by 4 is 56, divided by 33 will be your final value. So that was question number 4. Moving on to the next question, question number 5. Now a plus b upon a minus b, again remember componendo dividendo. Okay, so tan x can be written as sine x upon cos x, which is b upon a. So a upon b kitna ho jayega? Cos x upon sine x, right? Now I'll directly substitute their values. So a plus b upon a minus b will look like cos x plus sine x divided by cos x minus sine x. This is a plus b upon a minus b. Now the second term is reciprocal of this, a minus b upon a plus b. So just do the reciprocal of this. So cos x minus sine x upon cos x plus sine x. I want the square root of this, the square root of this, and the sum. Okay. Now take simple LCM of these two terms. So in the LCM, you will have under root of cos x minus sin x multiplied by cos x plus sin x. Okay. Now carefully, in the numerators, under root of cos x plus sin x whole square, that is cos x plus sin x, and then plus under root of cos x minus sin x whole square, that is cos x minus sin x. All right. Now in the numerator, I'll be left with 2 cos x. In the denominator, I will have under root of a minus b into a plus b. That is cos square x minus sin square x. Now cos square x minus sin square x is the formula for cos 2x. So the final value will be 2 cos x upon under root of cos 2x. Now since in the question it is not given what do you have to derive, okay, we just have to find out the value. So I'm leaving it here. This is the same thing, this is the same value that is in the answer key. All right. So that is question number 5. Let's look at our next question, question number 6. Now question number 6, there is like an error that is given in the practice exercise. So the right hand side is wrong. Okay, it should not be sine 7 theta sine 8 theta. Okay, this is wrong. So I will solve as per the formulas, as per the logic, and we'll see what will we obtain in the right hand side. Okay. So already they have given a hint. So you can express the right hand side and write it as 1 by 2 bracket 2 cos theta by 2 minus 2 cos 3 theta cos 9 theta by 2. Why we have done that? Because we have a formula for 2 cos A cos B. Okay, we have the formula for that. Now, what is the formula for 2 cos A cos B? So 2 cos A cos B, the formula is cos A plus B plus cos A minus B. Okay, so cos A plus B plus cos A minus B is equal to 2 cos A cos B. We'll use this formula. So we'll convert 2 cos A cos B in cos A plus B plus cos A minus B. So let's do that. So 1 upon 2 as it is. So it will be cos A plus B, that is cos theta plus theta by 2. That is 3 theta by 2. Okay. And then plus cos A minus B, that is theta minus theta by 2 is theta by 2. Done. Then minus, I'll use bracket because of minus sign. Now again 2 cos A cos B, again I'll write it as cos A plus B plus cos A minus B. So that is cos of 3 theta plus 9 theta by 2. So that is 15 theta by 2 plus 3 theta minus 9 theta by 2, or vice versa, negative aega, but cos of negative is positive only. Okay, so I'll write it as 9 minus 6, 3. So 3 theta by 2 cos 3 theta by 2. Okay, right? So I have applied the formula of 2 cos A cos B. So cos 3 theta by 2. Now you can see inside the bigger brackets, cos 3 theta by 2 will get cancelled. Okay, so I'll be left with 1 upon 2 outside the bracket. Inside the bracket, cos theta by 2 minus cos 15 theta by 2. Okay, so now inside the bracket I have cos A minus cos B. Now cos A minus cos B का formula ये क्या होगा? So let's have a look at that. Now cos A minus cos B can be written as minus 2 sin A plus B upon 2 sin A minus B upon 2. All right. So I'll use this formula. So half as it is. Inside the bracket, I will have minus 2 Sine A plus B upon 2. So theta by 2 plus 15 theta by 2 whole divided by 2. लिख देते हैं यहाँ पे theta by 2 plus 15 theta by 2 whole divided by 2 and sine A minus B upon 2. That is theta by 2 minus 15 theta by 2 whole divided by 2. Okay, right? So half as it is, inside the bracket minus 2 as it is, sine theta by 2 plus 15 theta by 2 will be 16 theta by 2, that is 8 theta whole divided by 2 will be 4 theta. Okay, then sine theta by 2 minus 15 theta by 2 will be minus 14 theta by 2. Okay, and that is minus 7 theta. Okay, minus 7 theta divided by 2, which will be, okay, minus 7 theta divided by 2. Sine of minus theta is minus sine theta. So take minus sign outside and 2 and minus 2 will get cancelled. So you will be left with sine 4 theta sine 7 theta by 2. Okay, so instead of this right hand side, which is sine 7 theta sine 8 theta, it should be sine 7 theta by 2 multiplied by sine 8 theta by 2. 8 theta by 2 is 4 theta only. So this is the correct right hand side that we require. All right, so that was question number 6 with some correction done. Question number 7, next one. Now this one is a very simple question. You are given the value of m and the value of n. Okay, and you'll have to prove that m square plus n square is equal to a square plus b square. So I'll start with m square plus n square. So m square plus n square. So you have m as a cos theta plus b sin theta, इसको square कर देते हैं. So a plus b whole square का formula apply कर देते हैं. So it will look like a square cos square theta plus b square sin square theta plus 2ab cos theta sin theta. Now this is m square. Now after this I need n square. So plus n square. So n is a sin theta minus b cos theta. Let's do whole square. So it will be a square cos square theta plus b square sin square theta minus 2ab cos theta sin theta. Okay. Now 2ab cos theta sin theta will get cancelled, right? Now combining these terms, a square cos square theta and a square, oh I'm sorry, so एक छोटा सा error कर दिया यहाँ पे, cos square theta sin square theta नहीं, उल्टा हो जाएगा यहाँ पे. So it will be a square sin square theta and b square cos square theta. Okay, so now you can combine these two terms, a square cos square theta plus a square sin square theta. So you will get a square cos square theta plus sin square theta, which is 1. Okay, and similarly do it with the remaining term b square sin square theta and b square cos square theta. So b square taking common, sin square theta plus cos square theta, right? The remaining part will get cancelled, 2ab cos theta sin theta. So final answer will be a square plus b square, as cos square theta plus sin square theta is equal to 1. Okay, so that was question number 7. Let's look at the next one, question number 8. Now they have given a hint, but I'll be using slightly different method, okay, to get the value of tan 22 degree 30 minutes. Okay, now 22 degree 30 minutes multiplied by 2 is 45 degrees. Okay, so this is the thing, this is the hint that we'll get. Okay, so I'll start with tan 45 degrees and we'll use the formula of tan 2 theta. Okay, so tan 45 is equal to tan 2 theta. So theta will be equal to 22 degrees 30 minutes, which is half of 45 degrees, right? So tan 45 degrees can be written as 2 tan 45 by 2 upon 1 minus tan square 45 by 2. Okay, now tan 45 by 2 is tan 22 degrees 30 minutes. So I'll assume K as, I'll do the substitution, K as tan 45 by 2, or this is equal to tan 22 degrees 30 minutes, which I actually require. Okay, now the value of tan 45 on the left hand side is 1. So 1 is equal to 2k upon 1 minus k square. Simplifying this, 1 minus k square is equal to 2k, or I can say that k square plus 2k minus 1 is equal to 0. Apply the formula of quadratic and get the value of k. So the value of k will be minus b plus minus under root of b square minus 4ac. So minus of minus 4 will become 4 whole divided by 2. Upon simplification, you will get minus 2 plus minus 2 root 2 divided by 2. So you will get two different values here. Root 2 plus 1 and root 2 minus 1. So these are the two values of k that we will get. Now since the value of tan 22 degrees 30 minutes should be less than 1, so I'll be picking up this value, so root 2 minus 1. Okay, you can rationalize it and take root 2 plus 1 in the denominator. You will get the same answer that is given in the answer keys. So why I have selected root 2 minus 1? Now the value of root 2 plus 1 is greater than 1. The value of root 2 minus 1 is less than 1. Now tan 22 degrees 30 minutes will be less than 1. So the answer will be root 2 minus 1. I can multiply and divide it by root 2 plus 1. Okay, so in the numerator I'll get 2 minus 1, that is 1, divided by root 2 plus 1, which you will see in the answer key. Okay, so that was question number 8. Moving on, next question, question number 9. Now prove that sine 4a is equal to 4 sine a cos cube a minus 4 cos a sine cube a. Okay, so for sine 4a, I will use the formula sine 3a plus a. Okay, so sine x plus y is sine x cos y plus cos x sine y. Let's do that. So sine 3a cos a plus cos 3a sine a. Okay, now apply the formula of sine 3a, which is 3 sine a minus 4 sine cube a. Okay, then cos a as it is, plus apply the formula of cos 3a, which is similar to the formula of sine 3a. So this is 4 cos cube a minus 3 cos a, and then multiplied by sine a, which comes as it is. Open the brackets, 3 sine a cos a minus 4 sine cube a cos a, plus the second bracket 4 cos cube a sine a minus 3 cos a sine a. Now you can see that 3 cos a sine a, 3 sine a cos a, they will get cancelled and you will be left with 4. I'm rearranging 4 cos cube a. First of all, this term 4 cos cube a sine a minus 4 sine cube a cos a, which is required in the right hand side. Exactly this thing is required in the right hand side. So that was question number 9. Okay, let's look at the 10th one, the last question for this video, and then we'll continue the remaining questions in the next video. All right, now you are given the value of m and the value of n, and you'll have to find out m square minus n square and prove that it is equal to 4 sine theta tan theta. Such an easy question. So m square लिखते हैं पहले. So m square will be a plus b whole square. Okay, so tan square theta plus sine square theta plus 2 tan theta sine theta. Okay, so this is n square minus n square. So n square is tan square theta plus sine square theta minus 2 tan theta sine theta. Open the brackets, tan square theta will get cancelled, sine square theta will also get cancelled, and you will be left with 4 tan theta sine theta, which is required on the right hand side. Okay, so the question, this one was pretty simple. Yes, this was actually short answer type question. Okay, so that was question number 10. I will stop here. All of you must wait for my next video, which will contain the remaining questions of the exemplar booklet of class 11 from the chapter of trigonometry. Meanwhile, if you like the way I'm explaining these things, please do like this session. Comment anything, like if you have any query, you have any question you are unable to solve, please post it in the comment section. I will make a video for those questions. Probably I'll solve that and post it in the chat box. All right, so please do comment, share this video with your friends and family, and subscribe to the channel. Like, you need to subscribe the channel so that you will get the notification of all the upcoming sessions. Keep watching and keep learning through these videos. All the very best. Have a nice time. Bye bye.